So today I'm going to do something a wee bit different. I'm going to actually work through some questions from past papers. So I'm starting off with the 2021 Foundation Tier paper. This is the summer series from 2021, and I'm going to look at a couple of questions here which were about reacting masses, or in that area. Okay? So looking at this question, this is the second part of a question. The first bit was slightly different, but I want to concentrate on the moles and masses calculations here. So when a sample of 8.1 grams of nicotine was burned, 16.5 grams of carbon dioxide were produced. Calculate the number of moles of carbon dioxide produced. So we start off just by writing down the formula. So number of moles is the mass divided by the formula mass. So in this case with carbon dioxide, I always like to write down how I work out the formula mass just at the side, so you can see there's one carbon, so that's 12, and then there are two oxygens, so that's 2 16, so that's 32. Add those together, we get 44. So then looking at the question, we take those values, so 16.5 for the mass and 44 for the formula mass. When you put that into your calculator, you will get 0.375 as your answer. So 1 mark there for that first part. Now the next bit, the theoretical yield of carbon is 22 grams. Calculate the percentage yield. Again, this is only worth 1 mark. I'm going to write the formula down for those of you who aren't sure of it. So the percentage yield is the actual yield divided by the theoretical, and then times 100 to make it a percentage. So from the last question here, the actual yield of 16.5 grams, it tells you the theoretical yield here is 22 grams. Multiply that by 100, put it all into your calculator, and you're going to come out with 75% for that one. Okay? So it says, in the same reaction, 0.35 moles of water were produced. Calculate the mass of water produced in grams. So I'm going to start here by just saying that the formula mass of water, H2O, is 2 hydrogens, which is 2, and 1 oxygen, which is 16, so that's a total of 18. Okay? So I want to work out the mass of water, and if we look at the formula that we used at the top here, we can rearrange that to give us mass is moles times the RFM. So the moles here is 0.35, formula mass is 18, and we work that out at 6.3 grams. That's the first part of that question. It went on into part C, so I'm going to have a look at that now. Just change these around. So in this section, it says another compound found in tobacco is ethanoic acid, which is CH3COOH. Calculate the mass of 1 mole of ethanoic acid. So effectively, you're just working out the formula mass here. So it is CH3COOH. So there's 2 carbons here. So that's 2 12s. And then I have 3 hydrogens here and another one here. So that's 4 hydrogens in total. So 4 1s is 4, and then in the middle I have 2 oxygens, so 2 16s, which is 32. Add all of those together and I get 60 as my total. Next, calculate the number of moles present in 540 grams of ethanoic acid. So we know the formula, moles is mass divided by the formula mass. We've worked out the formula mass in the last part of the question there. So 540 divided by 60, which is 9. So 9 moles for that part. And then this final bit here says hydrated copper to ethanoate as a salt of ethanoic acid. Its formula is this, CH3COO twice Cu.2H2O. So calculate the percentage of water of crystallization in hydrated copper to ethanoate. So the first thing you need to do is work out the total here for this whole thing. So looking at this, there are 2 carbons inside the brackets, so that means we have, and then 2 outside the brackets, so that's 4 carbons in total. So that's 4 12s, which is 48. There are 3 hydrogens here inside the brackets, and I'm ignoring the water at the moment, so I'm going to add it on at the end. So 3 hydrogens times 2 is 6 hydrogens. So 6 ones is 6. And then I have 2 oxygens here times 2, so that's 4 oxygens, so 4 16s, which is 64. And then I have 1 copper, which is also 64. I'm just going to write it over here so I can add them all up in a big long line. Now we know from the previous question here, I'm just going to put this back for a second. We know from here that the formula mass of water is 18. So you shouldn't need to work that out again in the same question. And we have 2 then of water, so 2 H2Os, 2 18s, which is 36. Now when you add all of that up, and I would ask you to do that on your calculator rather than just doing this in your head, you get 218. Now, the percentage of water then is going to be the mass of the water, so the total mass of water here, which is 36, divided by the formula mass for the compound, which is 218. And when you work all of that out, you get, and then of course, percentage, so times 100, and that is going to give you 16.5%. So that's the sort of question that comes up in the foundation tier. I'm going to do another couple of these for higher tier questions, which will have more of the style of questions you get for these reacting masses. Thanks for watching.